Okay, here's an example of a Bernoulli differential equation, first order. So I've got y prime plus p of x times y equals q of x times y raised to some power that's not 0 or 1. If that were a 1, I could squish this together with this, and it would just be linear. If that were a 0, if n were 0, I would just have a q of x over here. Again, this would be linear. Any other n here, this is nonlinear. So here's the way we do these. We're going to convert this into a linear DE by making this substitution. V of x equals y raised to the 1 minus n. Then, using power rule, v prime would be 1 minus n y to the negative n times y prime. That's implicit differentiation. Remember, y is a function of x. So make sure you understand this. Then, substituting in, if I solve here for y prime, so divide through by all this stuff, and for right here, plug that in, I'll get v prime over 1 minus n plus p of x times v, remember that's what v was, y to the 1 minus n, equals q of x. And we got that by taking the original and dividing everything by y to the nth power. Okay, so this is the key. This is where you want to start. You kind of jump from here to here. You make this substitution, and then you write this out. And then from there, it's now a linear DE in V that we can solve. So for example, we got this guy. Y prime plus 4 over xy plus x squared y squared. So n equals 2. Then I do v equals y to the 1 minus n, so 1 over y. That's my substitution. Then I just jump straight to here. This was equation 2 above. V prime over 1 minus n equals the old p of x, v, plus this q of x here. If you don't believe it, take the time to transform, actually making all the substitutions, see that you do get this. Of course, 1 minus 2 is just negative 1, so I multiplied everything by negative 1 to clean that up, and I get this linear DE. Okay, then we use integrating factors. Our integrating factor is e to the negative 4 over, or to the integral of negative 4 over x dx. That's negative natural log of the absolute value of x, which is, bring in the negative 4. That's natural log of x to the negative 4th power. The e and the ln cancel out. I get e, or x to the negative 4, which is 1 over x to the 4th. Multiply everything through by the integrating factor. I multiplied everything by 1 over x to the 4th. Check the details. See how I got from here to here by multiplying through by 1 over x to the 4th. Then the left-hand side is just product rule of v times the integrating factor. Check that. Make sure that's right. Then we do the antiderivative, both sides, dx. Antiderivative of the derivative, we just get v times, or v over x to the 4th. Antiderivative of 1 over x squared, negative 1 over x squared. Or no, it was positive, wasn't it? Antiderivative of 1 over x squared would be 1 over x. No, this should be negative. That was a typo right there. This is negative. This is negative. So there is a negative here. But that's okay. The antiderivative of negative 1 over x squared is 1 over x. The antiderivative of v 1 over x to the fourth, the antiderivative of the derivative of that is v over x to the fourth. Don't forget the plus c over here. Then distribute the x to the fourth over. But remember, we're not solving for v, we're solving for y. V was y to the negative 1, or 1 over y, so y will be 1 over this. So we have solved that Bernoulli dE.